Number 3, the velocity of a particle traveling in a straight line is given by v of t is equal to 50 minus 10 e to the negative 0.5 t meters per second, where t is greater than or equal to 0. Okay, A, state the initial velocity of a particle. Okay, so that means what is v of 0? So you plug in 0 for t there, and you will see that it's 50 minus 10 times e to the 0, and e to the 0 is 1, so it would be 40 meters per second. Okay, find the velocity of the particle after 3 seconds. Well, just like you did v of 0, you're going to plug in 3 for v. That would be 50 minus 10 times e to the negative 1.5. So there. And you have to use a calculator to find this. If it's not a calculator question, you would leave something close to this, right? And this is about 47.768 meters per second. Okay, C, how long would it take for the particle's velocity to increase to 45 meters per second? So I'll do the C here. So let's set it equal to 45. The velocity, let's set it equal to 45 and then solve for t. So that's 50 minus 10 e to the negative 0.5 t. Okay, subtract both sides by 50 and get negative 5 is equal to negative 10 e to the negative 0.5 t. Then divide both sides by negative 10, you get 1/2 is equal to e to the negative 0.5 t. Take the log of both sides, ln of 1/2 is negative 0.5 t, because ln and e are inverse functions. And then divide both sides by negative 0.5. Well, this is 1/2, so it's like multiplying by 2, negative 2 both sides. So t is equal to negative 2 times ln of 1/2. And if you put this in the calculator, that's about 1.386 seconds. Well, with 3 sig fig, it'll be 1.39. 1.39 seconds. Okay, but even before I started the part C, I knew this had to be between 0 and 3 seconds, because at 0, my velocity is 40, and then at t equals 3, it's 47, so 45 is right in the middle, and this is not moving, getting positive and negative, it's not moving around, so it's decreasing or increasing in velocity, right? So I knew it was going to be somewhere between 0 and 3. Right, part D, discuss the velocity as t goes to infinity. So what is the limit as t goes to infinity of this velocity function? Well, let's look at that. 50 minus 10 to the 10 over e to the 0.5 t. Okay, so this part right here, let me rewrite that. There. When t goes to infinity, this is going to get bigger and bigger. So 10 over a really, really big number is going to be approaching 0. So that velocity is approaching 50. So as time goes on, the velocity of the particle is going to approach 50 meters per second. Okay, E, show that the particle's acceleration is always positive. How do you find the acceleration from the velocity function? Well, you have to take the derivative, right? So if you take the derivative, let's say part E, so acceleration is going to be the derivative of velocity. So let's take the derivative of the velocity. That 50 goes away, and then negative 10, and derivative of e to dx is e to the, let's 0.5 t, and then you have to multiply by the derivative of the inside, which is negative 0.5, and you would get 5e to the negative 0.5 t. That's the acceleration of the particle. Now, it is changing, but if I rewrite this, 5 over e to the 0.5 t. This negative in the exponent doesn't mean the whole thing is negative. It just means this whole term is in the denominator. So this is always positive. So we've shown part E. Okay, so now part F says, oops, draw the graph of v of t against t. So what would that look like? Let's say, okay, here, and here's about 40, and here's 50. And when you start at t equals 0, you're about 40, and we know the limit as t goes to infinity is about 50. Right, so you have a horizontal asymptote there, and then when t is 3, so 1, 2, 3, my velocity was 47 point something, 47.768, right, at t equals 3, 47 point something, and at 1.39 seconds, my velocity is 45-ish, so it'll do something like that. Okay, and then next question is, G, find the total distance traveled by the particle in the first 3 seconds. Alright, so G, part G, is going to be, well, if you take the integral of velocity from 0 to 3 seconds of 50 minus 10e to the negative 0.5 t dt, this will give you the total distance traveled, right? See, I don't have to worry about like whether the function is positive or not, because when I graphed it, everything was positive, so the integral of that wouldn't matter. And it's not going from positive to negative, so I don't have to cut it into several integrals. So I just have to take the integral of this. At the end, you have to use a calculator, but you can at least get started without it. So here, that would be 50t minus 10, but then you have to divide by negative 0.5, so it's going to be plus 20 e to the negative 0.5 t. And because it's a definite integral, you don't need to put plus c because it's going from 0 to 3. All right, now if you plug in 3, you get 150 plus 20 times e to the negative 1.5 minus 0 plus 20, and that's because when you plug in 0 here, that e to the negative 1.5 times 0 is going to be 1. Okay, that would be 130 plus 20 over e to the 1.5-ish. And if you plug that in the calculator, you get 130 plus 20 over e to the 1.5. You get 134.462 meters, and then 3 sig fig will be about 134 meters. Okay.